Hello everyone, welcome back to another edition of James and Chris Science Videos. Today we're going to look at resistance and current in series and, well no, series circuits, so we'll do parallel circuits on another day. So what I've got here, we've got a very simple circuit set up. I have a cell, attached to the cell I have a light bulb, and attached to the light bulb I have an ammeter. And you can see when I attach them all up, the light lights up and the ammeter reads at 0.28 amps. Now, we talked about resistance in a previous lesson, and we talked about the fact that this light bulb here is slowing down the current. So what I've now done is I've now put a separate circuit where I've got a cell, I've got a ammeter, and now I've got two separate light bulbs. So if I put this into here, you'll find that the reading here has decreased. It is now down to 0.21. You'll also notice that the two light bulbs here have become dimmer. They're not as bright as the original light bulb. So what's happened here is as we go through a series circuit, and a series is where we go through component to component to component to component. You can see they're one after the other. Each of the light bulbs has slowed down the electricity, so we've actually had twice the effect. And so the current has reduced more in this one than in my original one. Now, a couple of predictions I'd like us to do. What do you think will happen if I put in 3 light bulbs? What do you think will happen to the reading there? So, let's try that. Let's see if you were correct. Let's put in this light bulb from over here, and let's put it into over here. And as we put this in, you'll see again it has dropped down to 0.20, but now the current isn't enough to make these light up at all. We've got this very, very faint glow. So each light bulb I add, the lower this current will be. Now, this is also quite interesting. Anywhere in the circuit, the current will be exactly the same. It makes no difference where the ammeter goes. So if I move my ammeter here, and I have it instead to that light bulb, and then I have that there. So now I've got my ammeter between this light bulb and this. That reading is exactly the same as it was the other side of the light bulb, and that's quite important to know. The current is going to be the same at any point in the circuit. It'll be 0.2 here, it'll be 0.2 here, it'll be 0.2 there, 0.2 here. And it doesn't matter anywhere in that series circuit where you put the ammeter, it will be the same. So that's fairly easy, isn't it? What I would like you to do is a couple of things. What I'm going to do is I'm going to produce a worksheet. On that worksheet are going to be a series of circuits. On each circuit, I'm going to draw ammeters. Remember, they are the circle with the A. On that, I would like you to work out or predict what you think will happen to the current in each one. And then just submit it back through Teams and we'll have a look at it then. Thank you very much. The next question, the last word of today is represents.